A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments, guys. Abhishek, I'm a little bit confused because I've started my preparation this August lacking revision so far. Should I appear for this year's examination or next year? Because the syllabus is diverse and I'm unable to manage my time. Abhishek, I would suggest to you that prepare as if you are going to appear for the examination this year itself. Okay? Please don't let yourself relax. In fact, I was today morning itself, I was having a conversation with one of the individuals who is in service right now. And why I'm sharing this anecdote is because that individual who is posted in Odisha, basically, he also had a kind of a similar doubt, a kind of a similar trepidation. And in fact, he had initiated the preparation in the month of January. But then, see, fix a very hard timeline for yourself and try to overachieve it on a daily basis. If you get into the habit of overachieving your targets on a daily basis, you have to put yourself through the rigor for the next 6 months, my dear friend. Those 6 months, think about it. If you put yourself through the rigor for the next 6 months, that can have a very, very good result, right? That can possibly alter your entire career going ahead into the future. Why I never advise the candidates to move forward or move their preparation to next year is because, first of all, we are online. So I am not able to actually track out your progress on a day to day basis. But then, here, always I have seen in the case of 99.9% of the candidates, and from very close encounters also I have seen that majority of the candidates whom I have suggested that okay, drop out this year and appear for the exam next year, it is the human brain which has got the mentality to relax a bit. And when you start relaxing a bit, that is when complacency kicks in, and you will find that even next year you are not. Even now, let me be very clear, my dear friend, even now, if you basically decide that each and every day, each and every minute, you have to make it count, you have enough time to crack the prelims examination and appear for the mains examination with substantial amount of content matter. And get one thing very clear: UPSC examination, clearing the civil services examination, is never about who is the most well read. Get that very clear. Write it down somewhere in the piece of paper, stick it on the wall in front of you. Clearing the civil services examination is never about who is the most well read amongst the candidates. If that would have been the case, only the PhD candidates would have cleared the examination, because nobody reads more books than the PhD grads. So that is why it is about who is the most well rounded, right? It is never about who has got the maximum in prelims. It is about how well rounded your preparation is, and still you have enough time, right? But if you keep on thinking that 1 month down the line I will start preparation, it doesn't work like that. So get very serious even from today. What is the worst that will happen? You won't clear it in the first attempt, but that experience of appearing for the mains examination, maybe you don't get to the mains examination, but that experience counts to such a great extent that you cannot even fathom right now. Because I'll tell you what happens in the mains examination. The sheer amount of materials that you have to revise, maybe one day before the mains examination, and that rigor of sitting through the examination continuously, paper 1, paper 2, in the evening, in the afternoon, again next day, paper 3, paper 4, then the optional, that takes a toll on your physical strength as well as much more than that, the mental strength. So let's suppose you don't get through even this year, your body would have been used to that, and automatically you will gain an insight that where is it that you want to improve your writing, etc. And You never know. Maybe you succeed this year. You had one of the candidates a few years back who secured rank 5 from geography optional. Now, that individual, he was very reluctant to appear for the mains examination. But after appearing for the mains examination, he said, I have written the things, but it is not that good. I might not qualify. He qualified for the through the mains examination, qualified for the interview. After interview, again, he was preparing for the prelims next year, that okay, this year maybe I will give a better attempt, and he got rank 5. So you never know how good your answer writing ability becomes as you put yourself and your mental strength through the rigor. So I would never advise you to postpone the examination. Never do that. Okay. Muskan, reservoir induced seismicity is basically when you have a dam structure which is built. Now, that dam structure, along with the huge amount of water which is stored, that imposes such a heavy weight on the rocks themselves that the rocks, they develop cracks and faults. And that is where eventually, through those cracks and faults, the rocks can get deformed. They will try to decompress, or they will have a relative movement with respect to each other, which will lead to the shaking of the earth's surface. That is reservoir induced seismicity. Okay, right. And here, Vishal, my mail ID is or get in touch. Okay. PU, just be very, very regular in the GS classes. What you are going through, be very regular and try to get in the habit, because you have a few years before you will actually give the attempt for the examination. Get into the habit of reading newspapers. Okay. Because newspaper reading, many of the candidates also think that, okay, 1 year before the examination, that much current affairs is required. That is when I will pick up the newspaper. No. But newspaper reading is a habit that you inculcate. Go to any of the MBA grad schools that you have, the IIMs, the good grad schools, the Indian School of Business, etc. You will find every individual there, despite the hectic class schedules that they have class schedules for around 8 to 10 hours on a daily basis. They still manage to read 2 newspapers and a weekly magazine as well. Now that is inculcated by them as a habit. It doesn't They don't have that habit before coming to the grad school. The grad school gives them that habit. So develop that habit. There will be many articles in the newspaper that you might not follow to the fullest extent, but once, let's suppose, by the end of next year, you get very regular in the daily reading of newspapers, you'll find that your day seems incomplete without reading the newspaper. And here I'm not talking about the analysis. Analysis should be used as a point of revision. As of now, because you have 3 to 4 years before appearing for the examination, explore. Explore what is happening in the world around you. Get interested in what is happening in the world around you. Automatically, it creates a lot of difference. Okay, right. And see, in case that you have a problem that in my locality you don't get the newspaper, you always have the e-paper facilities, right? One of the candidates, again, I will give you the rank, because obviously not many of them are used to the name being taken. But in the first attempt, he secured a rank of 368. In the second attempt, he secured in fact, in the second attempt, he secured a rank of 368. In the third attempt, he secured a rank of 109, and he's in foreign services as of now. He was very active during the G20 summit recently. Now, that individual, where he was living, you did not get the Hindu newspaper supply. So what he did was he basically downloaded certain apps that you have available online, where you can actually make notes online. So with that, for example, OneNote, Evernote, many of these apps are available. So from that Hindu newspaper, he could ably pick up certain data pointers, maintain a list of factoids, and that helped him immensely in the mains examination also. So you have to learn to capitalize. Please don't think about it that I have this disadvantage. How can you capitalize it? At the end of it all, just keep one thing in mind: 5 lakh candidates are going to appear for the prelims. 700 people are going to succeed, but your aim is not to get into that 700th. Your aim is to get into the top 200. Only then will you get a cadre, or only then will you get a service of your choice. There is no reason why you should relax. Try to find out your winning strategy. What works for you? What is your time schedule? Where can you extract the most out of it? The big four subjects: polity, economy, history, and geography. That is something you should have a complete grasp of, and you should be very regular in current affairs. With this approach itself, more than sufficient to clear the exam. Okay. Now, here we talk about, today we initiate the discussion about the aspect of distribution of volcanoes. So yesterday we had a discussion about the volcanoes, the type of landforms created by volcanoes, the various different types of landforms which are created. And also we observed that why and where the volcanoes they do erupt. We also looked at what are mantle plumes, what are hotspots, how is it that the mantle plumes they impact the earth's surface. And we observed with the example of volcanic hotspots. Now, did any of you manage to take a look at the atlas and observe where these volcanic eruptions that we had given the example of, where these are located? Any of you? Did you do that on your own? Very good. The expected names. So as I say, and probably all the faculties would also be saying that. So there are a few expected names. So good to know that those expected names are regular. So just do that basic things, okay? And there, just follow it up on a daily basis. The areas that we discuss, the regions that we discuss, you should take a look at the atlas or the Google map wherever possible, and get a detailed idea and analysis of it. Only then your understanding will be much greater, much deeper. Okay, fair enough. Even on Google Maps, if you have taken a look into it, fair enough. I want you to be aware of those. Now, today we discuss about the global distribution of volcanic eruption. Where is it that across the globe these volcanoes are situated? And then we will also take a look at the folding and faulting, and eventually we'll move on into the exogenic forces and the exogenic processes. Okay. Now, here, when we talk about the distribution of volcanoes across the globe, where is it that the volcanoes are situated? So the volcanoes are basically situated in the region of plate boundaries, plate boundaries, apologies for that. Actually, not feeling particularly well today, so I hope you are able to tolerate few of the gaps and intermissions in between. So here, when we talk about plate boundaries, so it is not on all the plate boundaries that you will observe a kind of a volcanic eruption. You will be able to observe the volcanic eruption in the areas of oceanic convergence, oceanic convergence, in the areas of divergence, of plates, not to be found in the case of continental convergence. Okay, certain areas of transform, Shalini, how much rank for IS within top 100 if you want a cadre of your choice? Transform plates. Also, excuse me, hotspots. So, for example, in the region of Hawaiian hotspot, and also another hotspot where you will observe this very frequently is where? In the region of Reunion Islands. Okay. So in these areas, no, not entirely in the Alpide belt. So in these areas, you will find a significant amount of volcanic eruptions to occur. Now here, majority of the volcanic eruptions will be observed in these areas. Okay, in these areas. So if a question is asked that where is it that you will experience or discuss about the global distribution of volcanoes, here you have to talk about that volcanic eruptions occur around the Pacific Ring of Fire. Why? Because there is oceanic convergence happening from all sides. It is oceanic continental as well as oceanic convergence, which happens on all different sites. So that is one of the main zones. Other than that, the mid-Atlantic ridge, the mid-oceanic ridge in the region of Atlantic Ocean, that is also an area where you will find significant amount of volcanic eruptions to occur. Other than that, you will also find it to be occurring in the region of, for example, the Mediterranean Sea. Why? Because here also an oceanic convergence is happening, because the Mediterranean crust is being pushed underneath the region of the European landmass. So there also you will find, for example, Vesuvius, Volcano, Etna, Stromboli. These are your volcanic peaks in this area. So these are basically the regions of volcanic eruption. So if you have to write a kind of an answer out of it, so first of all you have to talk about the fact that volcanic eruptions are generally observed in the certain areas, and for each of the regions you have to discuss in detail that why that eruption occurs in those areas. What is the reason for the eruption to be happening, to be occurring in those particular areas? That also you will have to discuss. Give as many examples as possible. Okay, for example, in 2022, you had a question which was asked that discuss about the major volcanic eruptions which occurred in 2021 along with the reasons for the same. Now, here, while discussing these, it is not as if UPSC wants you to name all the various different volcanic eruptions which have occurred in 2021. No. Now, in 2021 also, you basically had the eruption in the region of Iceland. You had one La Palma eruption there. You had the eruptions in the region of Philippines. And more importantly, much more violently, you had the Tonga eruption. Okay. So these were the major eruptions that UPSC wanted you to talk about. So discuss about those, give the examples and draw the schematic, rough schematic, that why is it that volcanic eruptions, they occur in this area. Okay. Now, here, this is the distribution of volcanoes. This is where you will have the Reunion Island. This is where you basically have the Hawaiian Island hotspot. These both are hotspots. This is a zone of convergence. This entirety of the region is a zone of convergence. Here you have the divergence which occurs in this territory, right? Here also you have convergence extending all the way to the region of Barren Islands. Now, here, if you will observe the region of Barren Islands, that lies to the, it is referred in pure geographical terms, if you refer to it, it is basically the northernmost volcanic eruption in the entirety of the Indonesian arc. It is the northernmost volcanic eruption in the entirety of the Indonesian arc. So that is the case of volcanic eruption? Will you be able to write an answer out of it? Is it something where you will find any difficulty? Please let me know. We can relate this with the convergence divergence map provided. Absolutely, yes. Right? So here I expect you to be able to craft an answer on Saturday when you will get the five subjective questions that you have to create an answer with that. So I will make it a point that I will give this global distribution as one of the questions. Try to create an answer out of it. Send it over to us for evaluation. And as of now, try to write as much answers as possible. Okay. Now here, please don't think about it that the main scare that the candidates have why they don't write the answer is that they are afraid that I won't be able to secure good marks. I will write a good answer and I will study everything, then I will create a good answer or a perfect answer. That day never comes. Try to think about it. For example, let's suppose take the case of the cricket players or any of the sports. Now they have to practice. They practice millions of times before actually implementing it on the field, on the ground. So think about it. The more you practice, the better you will be. So try to write the answers. It might not be perfect. It might not be up to the mark. But that is why you have the provision of getting the copies evaluated. Get the copies evaluated. Okay. Now, even when there is a slight delay in the evaluation, we ensure that the evaluation is only done by the people who have cleared mains examination multiple times. So they do know much more than the normal public about what is required in answer writing. Get their feedback. Okay. And don't think about it that I wrote this answer, it is perfect. A candidate, when they write the answer, they always think that my answer is the best, nobody could have written a better answer, but they don't know what others are writing for. So that is why try to improve, write the answers for this also, and you will improve. Okay. And here basically, no, while writing the answers, don't take the use of Google. Try to study the content as much as possible, but after that, get into that examination setting, fix the time clock. You might take a lot amount of time, but note down the time taken right now when you are writing the answer. Keep a record of it, that on 22nd of December when I was writing the answer, I was taking 20 minutes to write one answer. On 21st of January when I'm writing the answer, has it improved or not? So form your own data pointer, and accordingly you will be able to track your real time progress. Okay. Now, Prem, in that case, send a mail to me. I will take a look into it. Okay, right. Now, then we come to the concept of folding and faulting. Now, what is this? Now, we do know that the region of mantle is very hot and very dense. The density of rocks is very, very high. The crust is actually the coldest layer. All of us can agree to the fact that the crust is the coldest layer across the entirety of the planet. The coldest layer is the crust. Now, being the coldest layer, it is also brittle. Okay, so crustal rocks are very brittle. Means what? It means if the forces of compression or tension exceeds the elastic limit of the rocks, they can break easily. Right? So when we talk about the crustal rocks here, let's suppose the crustal rocks. Now you don't have all the rocks of the same type, right? So if let's suppose you have a certain type of a rock where you apply that, or if there is an application of compressional forces from interior, these rocks can always undergo a kind of a fold. Sometimes it can also happen that these rocks, rather than going for a fold, let's suppose if I talk about this piece of paper, now if I apply force on this piece of paper, it will get folded, isn't it? If I apply the force of compression on this piece of paper, it will get folded. But think about it, if I apply that force or that compression on this pen, will it get folded in the same manner? What do you think? If I apply the force of compression on this pen, what will happen? Will it get folded? No, it will break. It will develop a crack and it will break. If I keep on pressing it against each other, eventually one portion will override the other, right? One portion will simply climb over the other portion can go down. But the same force, if I apply on a different material, the material is indicating a different behavior. So that is why sometimes, depending upon the type of materials, the rock surfaces, they experience folding, or sometimes they can experience faulting as well. Faulting, what is faulting? I will talk about it in detail, but faults generally refers to as those kind of cracks which develop, deeper cracks which develop where you have a relative motion of rocks with respect to each other across those cracks. So that is what is known as faulting. So here, first of all, we'll discuss the process of folding. Now, what is folding? So, when you have rocks of a certain type, when they experience that compressional force, they get folded, right? They will get folded. Okay. Now, when the rocks get folded, observe that generally when you have the rocks which get folded, you have an upthrown path and you have a downthrown, a depressed area. That upthrown path, that is what is known as an anticline, and the depressed area, that is known as a syncline. So most often times, if you observe this kind of a compression of the rocks, there the upthrown path becomes the fold mountains, and next to the fold mountains, there is a kind of a depression or a syncline. So majority of the times, the rocks basically, they will get a fold like that. So here you have the anticline and you have the syncline. Are we comfortable up till here? If we are, then I can give you a real life example of it, which I hope doesn't put you out of your comfort zone. Right? Comfortable? Can we elevate the discussion a little bit? Okay, good. So basically, when you observe the formation of Himalayas, they are an example of what? They are an example of anticline. They are fold mountains. They are formed as a result of compression. Earlier, you had the Tethyan seafloor which got folded, and then you basically had the continental margins of the Eurasian and the Indian plate that started getting upfolded, isn't it? Now, proper and pure geographical theory, what it tells us is that every time there is such a significant anticline created, there will be a syncline created or a deep depression created as well. So, what is the depression when it comes to the Himalayas? Where is that depression? Can you venture a guess? That for the Himalayas, where is that depression? Sakshi, very good. Abdullah, very good. It is the northern plains. We will study about it when we come to the portion of Indian geography, that basically the northern plains, the sedimentary deposits that you see. So here you had the multiple folds in the formation of Himalayas, and then you had a downward depression, what was also known as the four deep. I will talk about it in detail when we come to Indian geography and the northern plains. This four deep concept, who provided it, everything. But here, that is where, over a period of time, when the rivers from the region of Himalayas would originate, they would accumulate all the deposited sediments here, and eventually this entire region got filled with sediments. It is these sediments that today we call as the fertile northern plains. So that is basically the case of folding. Whenever you have a fold which gets created, there will always be an anticline and there will always be a syncline getting created. Okay, right? I hope we are comfortable till here. So that is the case of fold. Now, folds are basically classified into different types depending upon how much pressure forces are acting. For example, let's suppose if the compressional forces are uniform. Let's suppose if the compressional forces are uniform, the fold which will be created will be like this, right? Now, it is symmetrical. From both sides, you have the equal angle to the peak. It is symmetrical. But let's suppose from this side, I'm increasing the force applied. Then observe the fold. So it was symmetrical. I have basically increased the force of from one side. What is happening? The fold is becoming asymmetrical. It is becoming isoclinal. Eventually, the fold, look at the fold. The fold has become horizontal now. If I continue to compress, if the force of compression continues to happen, what will happen in that case? A crack will develop here, and the remainder portion of the fold will simply start sliding over. So that is how, depending upon how much pressure is being applied, for how much time that pressure or that force is being applied, you have the classification of the folds into different types. For example, when we talk about the region of Himalayas, now, Himalayas have been experiencing that force of compression continuously for almost more than around 65 million years. That force of compression is almost continuous. So, as that force of compression is continuous, in Himalayas, in the region of the Shivaliks, you will find that symmetrical fold. In the region of the older Himalayas, the great Himalayas, you will find asymmetrical, the broken fold. The examples of that also will be found. So here, when we talk about the types of fold, you have symmetrical, asymmetrical, recumbent, and nappy fold. These are the different kinds of folds which you will end up finding. Okay, now symmetrical fold is basically here, somewhat like this. So in the case of a symmetrical fold, you will find that the axis makes equal angles from both sides. Okay, so this is what the side of the fold is, also what is known as the limbs of the fold. Okay, these are your limbs of the folds. These are basically the limbs of folds. So here you will observe, for example, observe how the symmetrical fold looks like. Now, from the top surface in a region, you oftentimes won't be able to distinguish that what kind of a fold is there, because the external forces, the exogenic forces, they would have leveled it out. So from the top surface, it appears to be absolutely symmetrical. Absolutely symmetrical here. So here, observe that from both sides, you have the equal angle. The rocks underneath, they are actually indicating a kind of a fold here. So this is a symmetrical fold where from both axes, it is having a kind of a same angle. So that is what we know as, that is what we refer to as a kind of asymmetrical fold structure. So here, this is your limb of the fold. In many of the areas, you will find that, let's suppose you have a folded structure like this, a folded structure like this. Now, the forces of nature out from outside, that is wind, rainwater, etc., they might flatten this area by weathering, denudation, degradation, etc. And that is when you will have this kind of a flattish portion from above. So from above, you might not observe that, okay, this is a kind of a such kind of a fold, but inside, observe the rocks, they are folded. So this happens when folding is caused by symmetrical forces from both sides, or if the folding has been initiated recently. So that is when you observe a kind of a symmetrical fold. Example, in the region of the Andes, that is where you will find that. Then even in the younger range of the Himalayas, for example, Shivaliks also, you will find this kind of a fold. So Shivaliks are also an example. They are also an example of the same. Then, if you increase the force of compression, then what happens? At that case, or in that situation, you have an asymmetrical fold. So, how can that asymmetrical fold be formed? So, let's suppose you have this kind of a fold, and let's suppose from one side it increases here. The compression increases. Now observe that the fold will not be uniform. Now again, from the surface, you won't be able to figure out that it is asymmetrical. Observe the surface. It appears to be very uniform. But observe the rocks here, the rock structure. Observe the rock structure here. They indicate a kind of an asymmetrical fold. Okay, so in the certain areas of Himalayas, in the region of Alps, there you will find asymmetrical folds to exist, and that is when there's a variation in the compressional stress from each side. That is, the amount of compressional forces that you will apply or that gets applied, when that varies, that is when you have the condition or the formation of an asymmetrical fold. So asymmetrical folds, they will give you an appearance like this. Okay, that is the case of asymmetrical folds. Then you have, as the folding increases, as the folding increases here, so in that case, you will find that as the forces they keep on increasing, eventually the fold ends up becoming almost horizontal, right? The folds actually end up becoming almost horizontal. So that is what is known as recumbent fold. So in the case of a recumbent fold, you will observe that this kind of a structure is observed. This kind of a structure is observed because the force of compression is quite significant. This is what is also known as horizontal fold, horizontal or sleeping fold. Okay. So here you will observe a kind of a sleeping or a horizontal fold getting created, right? So in this case, the actual plane becomes near horizontal. Now don't think about it that the mountains, etc., will start to look like this. It is not that case. It can also happen that a mountainous area looks somewhat like this, and inside it, the rocks get compressed to this extent. Okay, or the crustal thickening can happen like this. So that is basically the case of recumbent fold. So here, now if you think about it, uh, yes, and humble apologies for the minor interruptions and interventions, but uh, I hope we have the strength and I hope we have the power to carry on forward. And don't worry about it. The medicines, etc., have been taken. So let's hope for the best, guys. Okay. So that is today. You will have to tolerate me like that, but then I hope everything gets well. Okay. So, and as is the case, not every day you feel to the best of the health out there, and that is something that you guys also would have faced. So I hope that you can basically tolerate that for today. So here, when we talk about the recumbent fold, so here in the case of the recumbent fold, think about it that what can happen going ahead into the future. Let's suppose as you have this force of compression which continues to happen, as you have the continued pressure, compression, there will be significant amount of compressional stress which will be faced, and that compressional stress can eventually lead to what? From this portion of the rocks, there will be significant deformation. So here, rocks will exceed the deformation limit, can exceed the deformation limit or the elastic limit. From where the pressure is getting supplied. Pressure is continuously getting supplied with the help of the plate movement, the rock movements in the interior. So within the plate also sometimes this pressure is applied. So that pressure is applied from the internal forces. So when the rocks exceed the elastic limit, can we think or fathom about a scenario in which case you will find that here it breaks, and then as the compression continues to happen, this fold will start moving across it. After some time, this fold will travel further because now the rocks have broken. Okay, so that is the example, what we refer to as the broken fold, or what is also known as nappy. This is what is known as broken fold. So if there is a continued compression which happens even after the recumbent fold formation, that is what we refer to as the broken fold. Okay. So here, if you observe the nappy or the broken fold, you will observe what? Here, observe this. Observe the fold of the rocks and observe this pattern here. Right. So here, you have the rocks which have been broken, isn't it? You have the rocks which have been broken. So here, as the compression will continue, there will be movement which will happen across these rocks. Okay, so again I will tell you, again I will repeat this. So basically a recumbent or a horizontal fold is when, let's suppose, the compression from one side increases to such an extent. Let's suppose the compression from one side increases to such an extent that it becomes almost horizontal. Let's suppose it becomes horizontal. Now if you continue to push it, if you continue to push it further, what will happen? This will basically break here, isn't it? This is your horizontal fold. Then it will break here, and the continued forces of compression will shift this particular kind of a fold. So that is your nappy or a broken fold. In certain areas of Himalayas, particularly in the region of Great Himalayas, that is the Himadri region in Nepal, that is the Nepal Himalayas, certain rocks have developed that kind of a broken fold because the compression has been happening for more than 60 million years. So there has been a kind of a break which has developed, and because of that, it is continuously dragging along, it is continuously rubbing against each other. And some portions, the rocks across that point where it has broken, the rocks have actually moved forward by 8 to 10 kilometers. So think about it. So suppose here, at one point of time, there was this kind of a fold, then eventually due to the force of compression it broke. Now, as that compressive force continued to happen, this rock, think about it, moved further, had a further translatory motion for almost 8 kilometers. So that much amount of compression actually does exist, and it is provided from the interior of the planet Earth. But then that is not always translated in the same amount of deformation of the rock, and that is why the rock tends to break. Now, in this case, still we are talking about the type of rocks which can actually get folded. Still we are talking about the type of materials. If I apply compression, it can get folded. But what if, let's suppose I take this remote, right? I hope you are able to see this. Let's suppose I take this remote and I apply compression from both sides. Now if I apply increased compression, will this get folded? No, it will get broken. Let's suppose I take this mobile phone. Now, if I apply that force of compression, will it get folded? No, it will get broken. If I take this pen, I apply the force of compression, will it get folded? No, it will break. So certain kinds of materials, because of the compressional, or even if let's suppose there's a tensional pull, let's suppose I try to pull this out, right? Now I obviously don't have close to enough power to pull this apart. But let's suppose in some parallel universe, I had so much of power that I could pull this apart. Then what would have happened? It can get stretched, but eventually it will crack and it will break. Will it get stretched like rubber? No, it will simply break. So when such breaking happens, that is what is known as a fault. Now, not every crack which happens to develop on the surface, not every crack is known as a fault. Keep that in mind. Not every crack is classified as a fault line. Only few of them, they are categorized as a fault. So here, for example, let's suppose, and this particular portion can be relevant for your prelims. In the case of match the following prelims. So here, when we talk about the rock layers, they do not always respond to stress by folding. And rock near the surface are colder, and under less pressure, they tend to be brittle. Okay, so they tend to break easily. So they tend to break easily. Break easily. Okay. Now, a sudden stress on these rocks may reach the rupture point, resulting in cracking or breaking of the rock structure. If there is a breaking of rock, let's suppose a rock like this has developed a crack like this. Now, a mere or a simple development of a crack, that is never referred to as a fault. Okay, so here, this is what is known as a joint. So, a simple development of a crack, that is never referred to as a fault. But let's suppose the crack developed is so significant. Let's suppose this is your rock layer, the entire region I'm talking about, and imagine a larger area spread across many, many kilometers, maybe hundreds of kilometers also. So here, let's suppose there's a development of a crack. Now, if there is a tensional force, in that case, what will happen? If you try to pull this apart, now there can we imagine some amount of movement happening here? Some amount of movement happening here? Maybe you will have one portion simply sliding over each other. One portion, let's suppose there's a crack, it is getting, there's a tensional force. One portion might simply sink below because there is no support from the other side anymore. So when there is a relative movement happening across that crack, relative movement of the both sides happening across that crack, it can be upwards, it can be downwards, any kind of movement, then it is known as a fault. Again, I will repeat. If there is simple existence of a crack, it is not known as a fault. It is known as a joint. But if there's movement across the crack, where the rocks are now, the crack has become so vicious and so significant that there is movement across the rock, then you will have, that is referred to as a fault. So this is what is known as a fault. So when there is relative movement between the rocks on either side of the fracture, the crack is then called a fault. So this will be, if there's a relative movement of the rocks on both sides here of the crack, this is a fault. Okay, this is also what is a fault line. And the plane across which there will be an inclined plane of sorts across which that movement is going to happen, that is what is known as the fault plane. Okay, so that is what we refer to as a fault plane. So that is the case of faulting. Now you have different classification of faults based upon what kind of a movement happens, whether it is a compressional or a tensional force. You have further classification of the faults into normal fault, reverse fault, rift valley or graben, and also Horst. So for example, when we talk about the normal fault, now, normal fault is created due to tension. You have the tension. So here, imagine if you have a rock structure like this. I will tell you what kind of a movement, don't worry. So here, let's suppose there is a structure of a rock like this. Now, if there is a tensional force, let's suppose. Now the rock structure will start to weaken. As the rock structure weakens, eventually it might happen that a significantly vicious crack might develop. Okay. And as this crack develops, what will happen if you pull it apart? One portion can simply fall underneath. One portion can simply fall underneath, isn't it? So there is a kind of a slip. So that slip is going to happen across the entirety of the region. That slip is going to happen across the entirety of the region here. isn't it? Here, this portion of rock has simply slipped down the crack because the crack had developed due to the tensional force, and now the rocks, they basically are supported with each other. But if this support structure has developed a crack, it is not able to support the other one itself. This portion can fall down. So this is a kind of a normal fault. So it results from the tensional stress in the earth's crust. I hope, Ranjini, now you are able to understand what kind of a movement. Now here, because of that tensional force, there is a movement where the rock simply undergoes subsidence. Subsidence basically means basically moves down. So here you will find in many of the cases a very steeply inclined fault plane or a fault zone. That is what is known as an escarpment. This is what is known as an escarpment. Will earthquakes happen when you have these kinds of movement? What do you think? What does your logic tell you? Will earthquakes occur when you have this kind of a movement? Absolutely, yes. Absolutely, yes. There will be shaking of the ground surface. So there will be the kind of earthquake or seismic activities which will be observed here. So here, basically, you will observe that you get the case. Let's suppose you have a structure where the other portion has simply sunk down. This is the same thing which is observed across the western coast of India. That is why the western ghats, they are so steep in basic elevation. Western ghats, if you take a look at the structure, they have almost vertical wall-like formations, vertical wall-like structures that you have. Okay, so that is basically the case of an escarpment. Okay, so that is why the western ghats here, at one point of time, in the case of the western coast of India, you had a landmass significant. Now, when the Indian plate collided with the Eurasian landmass and the folding was happening, there was a significant amount of fault line which developed, and then eventually one portion simply sunk down. That portion is still underneath the region of Arabian Sea. Okay, and the remaining portion of the Western Ghats, they appear as almost steep vertical wall-like formations. So that is the case of escarpments. Example, Western Ghats. Okay, sir, can't attend your full live class today due to some medical issues. Fair enough. Take care of yourself and be better. So that is the case of normal fault. Vikalp, what could be the forces causing relative upward movement? Are these also due to the rising of magma? Sometimes it can be because of the rising of magma. Sometimes it can basically be because of the endogenic or the interior forces itself. So that is basically the case of why there is that relative movement. Anant, the last part about escarpment. So escarpments, they are created when there is movement across the normal fault. So this is the fault scarp. It is from this scarp that the term escarpment is derived from. So when you have a normal fault, in that case, one portion simply subsides or sinks. And as it subsides or sinks, the remaining rock portions, or better than rock portions, it is better to talk about the crustal layer. The remaining crustal layer having a steep wall-like slope is an escarpment. Is that understood, Anant? Any doubt till now? That is what we refer to as an escarpment. Example, Western Ghats. That is why on the western edge of the Western Ghats, you will find that substantial amount of land portion has basically sunk underwater. Now, then you have the reverse fault. Now, reverse fault. Obviously, something to the opposite of the normal condition. That is why the term reverse. So, when we talk about reverse fault here, this is created due to compression. Okay. So, normal fault was created due to tensional force. So, if you apply a compressional force, then what happens? Let's suppose you apply a kind of a tensional force, a compressional force rather. So if this is a rock structure, now you are trying to provide compressional force, and here, let's suppose you are trying to provide that kind of a compressional force, but the material is not such that it can get folded. So when you are applying that compressional force, what will happen? Maybe crack will develop here. Some crack will develop here. Right. Now, the further compression of it, what will it lead to? As the forces, they keep on acting, what will happen in this case? Can we imagine a scenario where as you apply pressure on from both sides, as you try to compress it from both sides, one portion simply moves up, one portion simply overrides the other? Can we imagine a scenario in which one portion simply overrides the other? It is simply pushed up the other portion. Can we have a scenario somewhat like this? Right? So this is where the movement appears to be against gravity. In the case of normal fault, there was this subsidence which happened because the rock which was providing its support was not supporting it anymore, is not attached to it anymore, so the other portion simply sunk. Imagine in the case of western part of India, here again I will take you back for a brief moment to the case of the normal fault. Imagine in the western part of India here, at one point of time you had the structure somewhat like this. Now, when the collision with the Himalaya and the formation of the Himalayas happened, the power was so significant that there was a large crack which developed here. Something like that happened even across the eastern coastline, around the region of the present day Bangladesh also. Now this rock, this particular portion has got nothing to support it at that height anymore, at the top of the crustal region anymore. So this portion simply would sink down, right? That is a normal fault which has happened. In the case of the reverse fault, one portion gets simply pushed up. So that is where it appears to move against the force of gravity. And that is why it is also what is known as reverse fault. So reverse fault is produced from compressional stresses where the upper block slides up the incline of the fault plane in reverse of the sense of the gravitational pull. So that is where you will observe this is the incline. This is the fault plane. This is where there is a kind of an, because think about it, whichever pen, pencil, etc. that you have, now if you continue to press it, eventually it will happen, one portion will override the other. Similarly here, it can happen that there can be a crack developed and one portion simply gets upthrown. So that is the case of reverse fault. right? So that is where we have the compressional forces. Now, in this case, will you experience earthquakes? Yes, absolutely yes. Example of this reverse fault. Okay. See, I will give you the example, but I don't want you to get confused out of your skin here. The Tibetan Plateau, the region of Tibetan Plateau is also the highest plateau across the world, now having an average height of more than 5 kilometers. Now, because of continued compression, what happened was that a reverse fault developed beyond the region of the Himalayas. Now, as that compression continued to happen, the land continued to get, the crust continued to get thickened and the land was pushed up. So that continuous movement across that reverse fault is one of the reasons which is responsible for the elevation of the Tibetan Plateau and the Tibetan highlands as well. So there you will get the example of this reverse fault. Understood? Are there any faults where earthquakes don't occur? So understand, when do we say it is a fault? When there is a relative movement happening across a crack, that is what is a fault, isn't it? Now, if there's a relative movement, will there be a shaking of the Earth's surface? Obviously, yes. So, always across the fault plane, there's a probability of occurrence of earthquakes. Always. Okay. Now, after that, we come across graben. What is the incline in reverse fault? Which incline are we talking about, Sushmit? That is what I told you. This is the case of the fault plane. This is the incline. This is the incline that we are talking about. Incline of the fault plane. So incline means the slope of the fault plane. Okay. Now, then we have a combination of these two, normal and combination of these two reverse faults. So when we have a combination of two normal faults, so that is when you have the formation of a graben. So graben or a rift valley, this also creates what is known as a rift valley, is created due to simultaneous occurrence of two normal faults. Krishika, I just gave you the example of a reverse fault. The Tibetan highland, the region of Tibetan highlands has been uplifted because of that force of compression. The hard rocks in the region of the Tibetan highlands, they could not get folded at the same rate. So that is why it developed a crack and it got upfolded. Okay. If these all things was happened, then sir, also possible one day whole earth will destroy. Whole earth will destroy how? What will be created if the earth will get destroyed? All these things are happening at the surface only. These things are surface phenomena because of the forces acting from interior. These things are surface phenomena. There is a continuous construction and destruction of the landmass, which is a feature of the crust. So it keeps on happening. Okay. In both the fault slopes are formed, yes. And also it takes millions of years, yes. So in this case, imagine here. Now, formation of Rift Valley also has multiple different theories. I will not take you into the depth of these theories for obvious reasons, not required for the general studies. In case you are studying optional, you will have to study that. So here, let's suppose you have the force of tension in this case. Now, it can also happen that simultaneously you have development of two cracks. Maybe a crack occurs here, a crack occurs here, or a joint. Now, over a period of time, let's suppose these cracks, they start to deepen. these cracks, they start to deepen. Right. So as these cracks, they deepen, then what happens? Now, if from both sides you pull it apart, what will happen to the central portion? There is nothing to support the central portion anymore. So can you imagine the central portion getting subsided? Can you imagine the central portion to simply fall down? Why? Because there's a tensional force from both sides. As the both sides are getting pulled away, the central portion simply falls down. Can we have our heads wrapped around this reality? Right? So this is what is known as graben or a rift valley. Okay, so many of the times the rivers, they take their way or they follow the path across this region of rift valley. So example of this rift valley falls down into mantle. No, it does not fall down into the mantle. This happens across again in the crustal layer itself. Right, now we do know that the crust is significantly thicker, around 20-30 kilometers thicker. So there itself, and understand that mantle can be slightly compressed or expanded because it is a solid material of very high density. So mantle can always end up experiencing slight amount of deformation and elasticity because of high temperature also. But when we talk about the region of the crust, it breaks. So there, it can happen that as the central portion sinks down, in the lower portion of the mantle, the materials get readjusted. That happens. So here, example of Rift Valley is basically Narmada Rift Valley. Very good. Narmada Rift Valley. Then you also have Damodar Rift Valley. Even River Rhine, very famously, when it drains through the region of Black Forest area in the region of Germany, there also it forms a rift valley. So these are the examples of rift valley structures. Ideally, you should basically look for the location of these areas. Where is it that River Narmada drains? And you will find the unique feature where River Narmada drains almost through a straight line. Unlike the other major rivers of the northern India or southern India, it drains almost through a straight line because there is a rift valley, right? Then even River Damodar in the region around, for example, up till the border of West Bengal, after which it enters the plain areas. Even in some part of southwestern Bengal, it drains through the hard rocky regions of the Chota Nagpur plateau. For example, in the bordering areas around Purulia, etc., there also it will be moving towards and from the region of the hard rocks of the Chota Nagpur plateau. River Damodar also for that part will exhibit a straight linear progress. So that is an indicator of it moving through a rift valley. Another example, East African Rift Valley. East African Rift Valley. Which topic are you talking about, Parul, that has not been covered in the class? See, please understand, I will repeat it again and again. It is not the case that I am following the exact contents of a particular said book. I am talking about those areas which are relevant in the examination. For example, in the books, any of the book you open up, will you find that much detail about the composite volcanoes or stratovolcanoes out there? Let me know. In any of the books that you open up, will you find these many stages of the formation of Himalayas? Do let me know. In any of the books that you open up, do you find these many stages and detailed explanation about the formation of planet Earth? Do let me know. So wherever it is important, I'm taking you to the deeper portions. That is why we are moving slowly, if you would have noticed. So, but which portion is it that you feel that has been dropped? Please let me know. And but have a bit of faith, my dear friend. We are going to cover those areas which will help you in the examination. That is why I always say, in the mains examination, out of the 105 marks in GS paper 1, 45 to 50 marks in GS paper 3 for agriculture, combined around 160 marks. I can assure you, roughly around 140 to 145 marks questions will be directly asked from the discussions that we have had in the class. Okay, so have some faith. Okay, so I don't think you are giving me the name of the topics. So see, now I cannot entertain that. Ranjini, in reverse fault, you said one portion will go uplift. If one portion will go downward, it looks like a reverse fault, Ranjini. But it is not a reverse fault because one portion is sinking down. But in the case of a reverse fault, one portion is getting pushed upward. Right. So by appearance sake, they will appear to look similar. For example, take the case of the Tibetan highlands. Now, Tibetan highlands, from the appearance sake, it will never give you the appearance that it is a kind of a reverse fault or a normal fault, but for that matter. But the height has continued to increase because of compressional force, the hard rocks, and that is the region where the Tethyan sea floor, as it was subducting, there were volcanic actions which happened, volcanic events which happened. So hard igneous rocks, they could not be folded to the same extent, so they were basically, it got pushed up. So, regardless of what it appears to look like, when you have an upward motion induced in the rocks, that is generally because of the reverse fault. When you have the downward motion or the subsidence motion, that is basically the case of the normal fault. Okay, right? Trench is not a reverse fault. Trench is basically created due to the subduction of the oceanic crust. That is why a trench gets created. Okay. Achal, the PPTs and the current affairs, along with that, if you want to revise, I hope you have the pre recorded lectures as well. So, pre recorded lectures also will do the work of any book that you revision through the pre recorded lectures, also will do the work of that. So, don't worry about it. If you want to revise it before the exam, just flip through the NCRTs of 11th and 12th. But let me say this with utmost amount of surety. If you have been regular for the 24 classes and not one of those students who suddenly appears, gives the guest appearance in the 5th class, 7th class, 12th class, and 15th class, you'll be able to, or you should be able to cover the NCRTs within 1 week, the entirety of 11th and 12th NCRT of geography. And 1 week also, I'm taking a longer period of time. Okay. Constituent of the solar system, galaxies, the sun, are these not important? Did you attend the first class, Parul? Were you in attendance in the first session, or have you simply taken a look at the annotations of the PPT? Be very honest. Because rest of you can vouch for it. In the first class, I had told you that I am talking about the theory of expanding universe. I am talking about the Big Bang theory, etc. But in detail about the entirety of the formation of sun, the nebula, the black hole, etc. That is something we will study in science and tech, or you will study in science and tech. I hope that is something that you guys would have heard, or that is something that you guys would have understood. Okay. So, Parul, kindly attend those sessions just by annotations of the PPT. If you think that it will be sufficient, please attend the class discussions also. Because otherwise, you could download the entirety of the PPTs at the end of 24 modules and your entire work would be done, my dear friend. But that is not the case. That is why we have these live discussions for 3.5 hours on a daily basis, so that we can go to certain depths, we can explore certain depths. So please attend these live sessions regularly. You will get a clear cut idea. Okay. And Varsha, no, absolutely not. Brajneet, is it subduction of Tethyan Sea would lead to the formation of Deccan hard igneous rocks? No. That was created due to different volcanism. I will talk about it when we come to Indian geography. And if you are patient enough, I'll tell you about the formation of the Chota Nagpur Plateau also, and how the entire Indian subcontinent gained its shape, how the desert got created. Everything I'll tell you in detail. Okay. Vikalp, in case of Rift Valley and Horst Valley, can we say that the middle portion is made up of same kind of substance? See, Vikalp, understand why. A question for from Vikalp is that if there is compressional or tensional force, why is it that a normal fault or a reverse fault is not created? Why a graben is created? So, if those forces they are applicable in a larger area, that is when multiple cracks can develop, and that is when some portion can simply rise up or fall down. Okay, so that is why when those forces are applicable in a larger area, multiple cracks can develop. If it is applicable in a smaller area, or if you have certain weak points in the rocks, there only one crack will develop. If you have multiple such weak points, multiple cracks can develop. Absolutely not, Mega. It should be fine. Now, here, when we take a look at the Rift Valley structure, observe here, there is an uplifted portion. Uplifted in comparison to the portion which has sunk down, there is a portion which is above the ground surface. Okay. Sushmita, by revision, repeat it as many times as possible. So here, observe, if you are standing at this region, at this place, for you, this will appear to be an elevated area, significantly elevated area, right? And over a period of time, the winds will erode this. The winds will be acting against it. Maybe if the rainwater or the significant rainfall happens, maybe small streams they come into existence, they will erode it, they will convert it into small hill-like features as well. Okay, so that is why graben or rift valleys are always associated on the sides with the hill-like structures, always. Okay, now here, then we come to the combination of two reverse faults. What happens? So when you have the combination of two reverse faults in a large area, again, due to that force of compression, let's suppose you have combination of two reverse faults. Now, in that case, first of all, let's suppose there's a crack developing here, there's a crack developing here as that compression is happening. Furthermore, as this compression continues, the cracks develop into a full-scale fault. And then there's a compression which is happening. What will happen to the central portion here? Will the central portion fall down? No, the central portion can be pushed up here. So here you will have the central portion which can get pushed up. So that is where you have the formation of a Horst fault. This is what is known as a Horst. Okay, over a period of time, it can also happen in the same way that the winds, rainfall, rivers, etc., they will erode this area to form a kind of a hill and many hill features, for example, in this area. Now, these kind of mountain systems, many of the times the land gets uplifted in such a way and then eroded, that you have mountain systems also which are formed like this. So these kind of mountain systems, they are known as block mountains. Block mountains. Example? Yes, Vishal, correct. Example? Vindhyas. Example, Vosges, very good, Mega. Vosges in Europe, Vindhyas in Central India. Now, Ashish has a good question and something which Muskan has also asked. Can a single landform have graben and reverse fault together? Think about it for a brief moment of time. And Muskan, your question is that can be called the graben as two sides reverse fault and Horst as two side normal fault. Yes, that is true. Now, Ashish's question is, can a single landform have graben and reverse fault together? The answer is yes. How and why? So again, whenever you have this kind of a query, always keep one thing in mind, that the planet is very, very old. There are multiple such actions, forces which have taken place over a period of time. It can happen that in an area, let's suppose the region experienced some tensional force. There was formation of a rift valley, right? And then the tensional force stopped after maybe 2 to 3 million years or 4 million years for the formation of a rift valley. After that, the tensional force stopped. And listen to this carefully. When the tensional force stopped, at that point of time, can we say that the cracks and the faults, they were created when the graben was created? Simultaneously, deep cracks and faults were created on the surface. Can we think about it in that way? Are we comfortable up till here? Right? Let's suppose after some time, after maybe 60 million years, 50 million years, let's suppose, there is a kind of a further push into that rock system. Further, that rock system is getting pushed. Maybe it is not able to move at the same rate as the push is happening. Maybe there is some compression. Now you already have the cracks which are developed. Now, across these cracks, can we expect that because there is a compressional force, the surrounding landmass can start rising up? Can we imagine a scenario like that? That the surrounding landmass can then start rising up because across that fault line, the fault line has reactivated and now there is compression after 50, 60 million years ago. So, in that case, to the sides of the Rift Valley, can we expect the existence of Horst in that area? Right? So, that is why it can happen. Okay? Having said that, under normal general parlance also, when you have a graben or a rift valley structure, the surrounding areas, they take the shape of a hill-like portion because of erosion, etc. So there you can have the presence of certain hill-like features. On both sides of the graben, you can have the portions which have remained elevated, right? Now, if let's suppose this portion is eroded into isolated hill-like structures, what kind of a mountain will you call them? Will you call them as a fold mountain? No, folding has not occurred here. Here, the creation of a hill or mountain is purely because of the fault creation, the movement of rocks with respect to each other. So this will also be called as a block mountain. So generally across the regions of the Rift Valley, you will find the existence of block mountain structures. Example here, example of it will be, let's suppose you have the Narmada Rift Valley, let's suppose. On both sides of Narmada Rift Valley, what do you have? You have Vindhyas on one side and Satpura on the other side. right? Vindhyas are examples of block mountain, of block mountain. Okay. Dwarka, which has sunk, can be an example of a normal fault. Anjan. Mountains in villages are block mountains too. Depends upon which village are you living in. If you are living in a village in Uttarakhand, it is a fold mountain. If you are living in a village across Western Ghats, what you are seeing is an escarpment. If you are living in the village in Rajasthan, what you are seeing is a remnant of a fold mountain. If you are living in the region of a Jharkhand, what you are looking at is the hills that you are Jharkhand, Odisha, Chhattisgarh. Many of them are intrusive volcanic landforms which resemble the hill-like features, or volcanic hills for that matter. If you are living in the region of central India, you are able to observe that kind of a block mountain structure. So depends upon where you are living. So Schmidt, you want to say that block risen up eventually forms hills due to erosion, and Graben becomes a depressed area. Rift Valley is also always a depressed area. Okay. Normal fault and reverse fault can occur in smaller as well as, but Graben, yes, Nikat, that is true. Generally, in larger areas, you will have multiple of these normal or reverse faults formed at the same time. Okay. Jyoti, without the pressure from interior, how a block of rock can rise up? It can deform. No. See, ideally the rocks will deform. But what if, that is why I gave you the example, if you have a compression in this kind of a material, sedimentary rock, it will get folded. But what if you have some compression happening across this hard rock structure? Then what will happen? Will it get folded? It will get broken. The central portion will rise up in that case. Okay? Graben or rift valleys, Mehtab, that is correct. Yes, Prem, that is true. Isn't Graben and host interconnected? If middle land is Graben, then other two sides appear to be host. That is true. Okay. So that brings us to the end of this particular chapter, and we move on to the next chapter about landforms which are erosional and depositional. Now, from this area, this is largely relevant for your prelims, and in prelims, you can get questions about basics of weathering, basics of mass movement, then types of landforms, erosional and depositional, and agent of nature such as wind, river, glacier, etc. Agent of nature responsible for creation. Then in the mains examination, for a long time UPSC restricted the mains type question from here only in the optional area. But this year and last year, UPSC has asked questions from this area in the mains in GS also. So here, again, basics of weathering and erosion. Weathering and erosion. Then you will have types of landform, and also properties of stages of river movement. River movement. Okay, it is from this area that you can expect questions to be appearing from. But before we initiate the discussion, we shall take a break and we shall be back by around 7. So let's take a break, 15 minutes break. Okay, and we shall be back around 7. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So now we talk about the various different types of forces which act from the outside of the earth. Now, till now, in our entirety of the discussion that we have held till now, we have discussed about the plate movements, we have discussed about the folding, faulting, earthquakes, volcanoes. Now, the forces which lead to the creation of these, where are these forces acting from? All these forces are basically acting from the interior of the surface, isn't it? All the forces that we have talked till now, and the entirety of the portion that we have talked till now, that is basically a resultant of the forces acting from the interior, right? Maybe there is a kind of a vertical movement, maybe a kind of a horizontal force which is acting, but it is the force which is acting from the interior that is what is leading to these circumstances or these kind of actions. So the forces which act from the interior, they are what are referred to as endogenic forces. Endogenic forces. That is forces acting from interior. From interior of the planet. Okay. The forces which act from the interior of the planet, they are known as endogenic forces. Right. Now, we have seen what kind of events can be caused because of these endogenic forces. These can lead to upliftment of landmass. These can lead to subsidence of landmass. These can lead to compression of the crust, folding. These can lead to expansion, creation of a fault line. These can lead to volcanoes. These can lead to earthquakes, isn't it? So the forces acting from interior have the power to create mountains, valleys, plateaus, all the various different types of structures, etc. But then simultaneously, at the same point of time, you have very powerful forces acting from outside the surface. And when we say very powerful forces acting from outside, what do we refer to that by? So let's suppose in a region, let's suppose in a region, due to the internal forces, there has been a mountain or a hill like feature which has been created. Let's suppose a mountain or a hill like region which has been created. Let's assume. Now, let's assume there is a powerful movement of the wind here. Now, can you have the imagination that these winds slowly and steadily will carry away the finer particles away from here? Maybe they will weaken the hill or a mountain structure. Then, let's suppose this area experiences lot of rainfall. Lot of rainfall. If let's suppose the materials in this hill or a mountain are made up of materials such as iron or limestone, can we have the imagination that basically that water will start dissolving the materials and will start to flow away with it? Right? We can have an imagination of that. Or it might happen that over a period of time, due to heating, cooling, again subsequent heating, now heating leads to expansion of materials. Rocks also will tend to expand. Cooling leads to compression of materials. The rocks will also compress. So that continuous expansion, contraction, etc., that can weaken the rock structure. And this top portion of the rock, it gets weakened, and over a period of time, this hill will be reduced to a smaller size. Again, the process will be repeated. Eventually, what will happen? Let's suppose there is another event here. Let's suppose there's a river moving here. Now, that river, as it is coming down the slope, it will have immense amount of speed. It will possess immense amount of power. So it will take away the rocks. It will drag away the rocks from their original position. The hill will get weaker. The rocks will get weaker. Eventually, after this, you can expect a hill, which was earlier a mountain, to be reduced to a much smaller size. This process will continue. Continue till when? Till the forces of nature have leveled the land. So, the forces acting from the exterior of the surface, they are also very, very powerful. That is why these external forces, these are also what are known as levelers. These level the land masses, right? These level the land masses to a certain degree. So that is basically where you will observe that the outside forces, for example, can we find an example of this around us? The example is the case of Aravallis. Aravallis, at one point of time, were amongst the highest fold mountains of the world. Many, many millions of years ago, Aravallis were very, very high. Think about it. I am sure most of you would know about the height of Aravallis now. The average height is less than 1,000 meters. Maybe 200, 300 meters is the average height of the Aravallis. At one point of time, the Aravalli mountain ranges were so very high. It would have snow-capped peaks, and it would have massive glaciers originating from the top of Aravallis. But look at the condition of Aravallis today. If, let's suppose, you have had significant amount of energy, your health is fine, you can basically climb up a hill and come back down within one day. Can you think about doing same thing in the Himalayas? Absolutely not. So at one point of time, from amongst the tallest mountain ranges of the world to the hill status of the Aravallis, what happened? The external or the exogenic forces, they have started leveling it out. Eventually, it will happen. Aravallis will no longer be the hills also. That is why Aravallis are also referred to as the residual hill or the remnant hill structures, because everything gets leveled. Okay, so that is basically the power of the external forces. Are we comfortable up till here? Can we push our imagination to this extent? Perfect. Himalayas. So when we talk about Himalayas, the height of the Himalayas is still increasing. We have discussed that. Why is it that the height of Himalayas is still increasing? Why is it that the height of Mount Everest has increased by a few centimeters in the past 50, 60 years? Because of compression. Why is that compression happening? Because of endogenic forces. Forces from the interior are driving the Indian plate towards the Eurasian plate. That is why that compression continues to happen. Now imagine a circumstance, maybe 15 million years or 50 million years into the future, where the Indian plate is not going to move anymore. Let's suppose the convection current which is pushing the Indian plate northwards, that convection current dies. There is a convection current somewhere else. So in that case, what will happen? The height of the Himalayas won't be increasing anymore. But then the outside forces will continue to act slowly, steadily, but continuously. Wind will be very powerful at that great altitude. Glaciers will continue to erode the rocks. Rivers will continue to take away the deposits from those rocks. So once the internal movement which is pushing the height of the Himalayas upwards, once that internal movement stops, then what do you see? Do you see a situation where the height doesn't increase anymore, but the height starts to decrease? So that is something which is going to happen in the region of Himalayas also. For example, in the entirety, those of you living in the part of the from, let's suppose, Madhya Pradesh, Chhattisgarh, and Madhya Pradesh, in fact, Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, even Haryana, Delhi, then, for example, Jharkhand, even Meghalaya, and southwards to it, Odisha, Maharashtra, in your surrounding, in your locality, you would have observed various different hills. Now, do you think the height of the hills has always been like that? At one point of time, these were volcanic mountains, just like what you see as Mount Aconcagua, close to around 6,900 meters above sea level due to volcanic eruption. Mount Kilimanjaro, more than 5,000 meters due to volcanic eruption. Similarly, in Chota Nagpur Plateau, in the region of Garo Khasi Jayantia, in the region of Chhattisgarh, in the region of Odisha, in the region of Karnataka, you had many such large hills. But now you don't have them. Why? Because the outside forces, they have removed them. That is why the forces acting from the interior, they are also in total what are known as tectonic forces, endogenic forces. They are also known as tectonic forces. And the forces acting from the outside, they are known as the exogenic forces. They are known as levelers. And this is a continuous cycle of nature. Please understand that. Anything, excuse me, any portion which has been created will get destroyed. Any upliftment which has been there, it will be run over by the outside forces. Newer portions might have a different elevation and elevated areas formed thereby. But the existing areas, they do have a tendency to get destroyed. That is where there's a consistent balance. Endogenic and exogenic forces, they keep on acting. The moment from the interior, the tectonic forces or the internal forces, they weaken, they reduce. Overall, the exogenic forces take over and they will level out any particular piece of area. So that is the case of the exogenic forces. Are we able to understand this? I will give you another example. All of us are aware where Appalachians are. All of us? Yes, Jyoti, that is correct. Where are Appalachians? In which part of North America? Eastern part of North America. Very good. In the eastern part of North America. Yes, Meghna, that is correct. So, in the eastern part of North America, do you know how Appalachians were created? Even though we have talked about it, but when we were talking about the Wilson cycle, excuse me, when we were talking about the Wilson cycle, what did we talk about? That the continents, they break into different parts, they come together to form again a supercontinent, again they break, again they form the supercontinent. Now, millions of years ago, hundreds of millions of years ago, you had a situation where that part of the landmass, just like you have the northern portion of India as an active plate boundary, eastern portion of North America was also an active plate boundary. It collided with the Scottish Highlands, the region of Europe, what is referred to as the Hercynian group of mountains. You don't have to go into the details of it. Now, these Hercynian group of mountains created the Appalachians, created the region of the Scottish Highlands also. But at that point of time, the Appalachians were very high. It is said to have been the source of multiple rivers. But then something happened. There was a convection current which emerged in that area. And North America and Europe started moving away. There was a creation of a mid-oceanic ridge there. Atlantic Ocean got created. Now, Appalachians today are much lower in height as compared to what they were when the folding had happened. And also, for example, are we aware about Colorado Plateau? Where is Colorado Plateau? Are we aware of that? Have we heard the name of Colorado? No? Okay. Locate that in the map today. It is in the western portion of North America. That is the area of Colorado Plateau. That is where you will find many of the canyons, deep canyons, etc. Now, in Colorado Plateau, for that matter, at one point of time, there were volcanic eruptions which created a plateau-like structure. Now, tectonic forces basically lifted that up. We have seen that faulting, folding, etc. can happen, can lift the landmass. Certain landmass can go down as well. So basically, the Colorado Plateau was uplifted. When that Colorado Plateau in itself was uplifted, then what happened? Basically, it was eroded slowly and steadily. Its height reduced. Again, there was another phase of uplift. Again, there was that erosion. It is going for the next phase of uplift as of now. Similarly, while you are locating Colorado Plateau, I also want you to locate the Ozark Plateau. And see, it is not a particular rocket science that how do I locate things in map. Just look at that region in North America. In the physical map, you will find that. Ozark Plateau, right? Are we aware where Ozark Plateau is? It is to the west of Appalachians. Southwest of Appalachians is where you will have the Ozark Plateau. Ozark Plateau for the past few millions of years has gone through multiple different phases of uplift, erosion, again uplift, again erosion, again uplift. Now, why to go so far away when in India we have so many diverse features? I hope you would all have heard about the name Chota Nagpur Plateau in the region of Jharkhand. Now, there, the capital city of Jharkhand, that is the region of Ranchi. Ranchi is quite unique in terms of the geomorphic landforms that you observe. There also, you have that multiple different phases of uplift, eroded, again uplift, again eroded, again uplift, again eroded. That is why in Ranchi you will find batholiths now. Batholiths, they appear as isolated hill-like features. Those of you belonging from that area of Ranchi, you would have observed that in the vicinity of Ranchi, for example, you will find some isolated hill-like structures. Now, why is that left? The outside exogenic forces have removed all of them. Some small hilly areas of hard rocks are left behind. Batholith structures, lopolith structures, they are left behind. So that is how powerful the exogenic forces are. The Himalayas are consistently getting eroded. If the Himalayas would not have been eroded, where would the sediments for the northern plains come from? The Western Ghat is consistently being eroded, forming the tiny and the thin Western coastal plain. Now, in the region of the east, the land is much older, very, very old. Certain areas, for example, Chota Nagpur Plateau, there the rocks, they are estimated to be more than 2.5 billion years old. Imagine 2.5 billion years old. So the erosion is much greater. Multiple streams would have existed. Today's day, Even in our own lifetime, we are able to witness the weakening of certain river systems. You would have heard about the news story that if we don't save this river will disappear forever. Within our own lifetimes of 30, 40 years, we notice these things. Imagine the time period of 2.5 billion years. Multiple such rivers, large rivers, would have been in existence when India was still very much part of the Gondwana land or Pangaea or prior to that. That is why across the eastern part of India, much greater erosion has happened. And that is why the eastern coastal plains, they are very, very wide, much larger amount of deposits also. So, what I'm trying to convey here is that there is a consistent balance between the endogenic forces and the exogenic forces. Any of them, when they become powerful, there is a change. For example, if the endogenic forces are more powerful, in the case of Himalayas, the height is increasing. Now, Aravallis were formed billions of years ago, more than 2.5 billion years ago, due to a kind of a collision. At that point of time, you did not have the entire subcontinent as India. You had small land masses which eventually got together. So Aravallis at that point of time were formed when you had a small crustal portion colliding with an oceanic crust, forming that fold, just like Andes and Rockies of today. Aravallis were also created like that. That is why in the region to the west of Delhi, southwest of Delhi, those of you belonging from the area, for example, around Manesar, slightly to the west of Manesar, that you around the region of Pataudi, right? You will find the evidences of old calderas also. So that tells you that there was volcanic as well as folding which had happened. Now, there is no such movement in that area for millions of years. There has been no such movement. Look at Aravallis today. And for that matter, Aravallis at one point of time extended from the region of northern portion of Gujarat, today's northern portion of Gujarat, all the way till Haridwar. Today, you cannot even have the imagination that at one point of time you had a mountain range and a mountain system crossing the region of Delhi. But if you go to the outskirts of Delhi today, you'll find the dry, slightly uprised area. That is what is referred to as the Delhi Ridge. Those of you belonging from Delhi or the outskirts, you would have heard the name Delhi Ridge. You have a lot of scrubs in that area. Now, in that region, what you call as the ridge at one point of time was a mountain. It has been eroded away. So that is a natural cycle of erosion, natural cycle of degradation, where the exogenic forces, they try to flatten out any kind of building which is there. And they will continue to flatten it out until and unless they reach the sea level. Then they don't have that downward force anymore. And then up till the sea level, they will basically carry out the materials from one area, from an uplifted area, and deposit it to some other area. Again, they will erode some materials from certain area, deposit it in some other area. So that is the case of what results in various movements across the earth. Okay. In today, there is news about Iceland volcanic eruption. But haven't we been talking about the Icelandic volcanic eruption for the past 2 to 3 days? Uh, I hope you are aware what kind of volcanic eruption is in Iceland. What kind of category of eruption do we observe in the region of Iceland? Can we have a quick recall? Not active, obviously not. I'm not talking about active, dormant, or extinct. Fissure volcano, very good. So you have a fissure volcano there because of the divergence of plates. So I don't think you should have any difficulty in understanding that. In fact, you should be able to relate to it much better. Now, the broader classification is endogenic and exogenic forces. This is the broader classification. Now, in the case of endogenic forces, it is classified into sudden force. Sudden forces means it happens all of a sudden. right? So, for example, earthquake, volcanoes, they happen in a quick time interval. You won't come across a news story that, you know what, there was an earthquake which was happening in Kathmandu, and Kathmandu is still shaking continuously for 800 years. No, earthquake happens for basically few seconds, a minute at max. Maybe another earthquake happens, but every time an earthquake happens, that shaking of the earth's surface is observed for a brief moment. Same is the case of a volcanic eruption. It will happen maybe for 1 year or maybe for 6 months. That's it. After that, it will cool down. Again, that region might erupt, but it is a sudden eruption. So these come into the category of the sudden forces. Then you have the slow acting forces. These are slow acting forces, which happen very slowly. For example, let's suppose there's a creation of a reverse fault. Now, reverse fault leads to the upliftment of the landmass. The existing landmass you will observe, or let's suppose there is heat from the interior, which has led to the swelling of land. Now, will that swelling happen overnight? No, it will be a slow process. In the first day, you might have a swell like this. In the second day, you might have a swell like this. In the third day, you might have a swell like this. Or not in the first or second day, but rather in the first 1,000 years, in the second 1,000 year, or in the third 1,000 year. So that upliftment of the landmass, wherever it is happening, it will be very slow. Maybe 1 millimeter every 10 years, the land is rising up. Maybe 1 millimeter in every 50 years, the land is rising up, or the land is sinking at a very slow rate. Or when we talk about folding, the formation of Himalayas in itself has taken more than 65 million years. Now, 65 million years is not a short time period that we are talking about. So, what is that? That is basically a slow acting force, isn't it? So, these are what are referred to as basically the diastrophic or the slow acting forces. These are further classified into aperogenic and orogenic. I'll come to the exogenic forces later, but let me introduce you again to these terms which we have already studied. Orogenic, we have already studied. Aperogenic, also, we have already studied. Now, diastrophism is a slow acting process. So, it is the process of deformation that changes the Earth's surface. Okay, the Earth's surface in itself witnesses a drastic change. Now, it produces many of the basic structures that we see on the surface. For example, I have just told you that formation of Tibetan highlands is associated with what? If someone asks you, what is the reason for the significant height of the Tibetan highlands? What will be your answer? Upliftment of land because of reverse fault formation, isn't it? But do you think that Tibetan plateau, it has uplifted to an average height of 5 kilometers above sea level overnight? No. This process of compression and then further upliftment of the land has happened in the past 60, 65 million years ago. So that is why it is a very slow acting process, right? Then mountain formation, fold formation. So basically, there can be compressional force, there can be tensional force, there can be forces of shearing. Shearing means a kind of a relative motion with respect to each other. So that is diastrophism. Now, diastrophism, when it leads to fold formation, then it is referred to as orogenic. So diastrophism is further classified into aperogenic and orogenic. Aperogenic, which can lead to the vertical upliftment or subsidence of a large mass of land. So let's suppose in a tensional force we have Have we not seen about tensional force, Lakshmi? When, let's suppose, you have the convection current, the horizontal component of convectional current, have we not seen there? Or let's suppose the uh, a landmass is moving in a certain direction, and one portion of it is not moving at the same rate as the other. There is a tension there also, right? Now, yes, Lakshmi, that is correct. Shearing is basically shearing transform fault or the transform movement of plates, for example. That is what is shearing. They move with respect to each other. Transform movement. Is that understood? Yes? Now, these, for example, when we talk about aperogenic, so let's suppose a land is like this in a certain area. You have a land which is somewhat like this. Okay, let's suppose. Just a moment. Excuse me. So, let's suppose in a certain area, you have the land which is like this. Now, it can happen that the internal forces are leading to an uplift here in this area. In this region, let's suppose there's an uplift which is happening. Maybe a host or anything is getting created. Now, this region will not get uplifted overnight. The rate of uplift or the rate of subsidence in that area, in the case of a Rift Valley, can be at the rate of maybe 1 centimeter per 10 years. Maybe. Imagine how much is 1 centimeter. In whichever area that you are living, you won't even be able to distinguish if the land around you has basically increased or moved by 1 centimeter. 1 centimeter is almost inconsequential in our day to day lives. Right? So let's suppose after 1 year or after 10 years. So in 10 years, it is 1 centimeter. So 1 millimeter every year. How much is 1 millimeter? You cannot even measure 1 millimeter out there without your scale and even your plastic scale. You find it very difficult to measure 1 millimeter, isn't it? Now imagine that you have a. Are we comfortable up till here? Only then I will take the concept further. We are comfortable up till here? Yes? Can we take the concept further now? Right? Good. So here, see guys, I am deliberately taking it slow, but at any point of time, if you are uncomfortable, do let me know. First of all, I'll clarify, excuse me, if that is required for your GS or not. And then if required, I'm repeating it also. Okay? Explain again. What? What do you want me to explain, Garima? The entire thing? What is it that you want me to explain? You have to elaborate upon that also. Okay. Till the time that you frame the question, let's move forward. Aperogenic forces are those forces which lead to the uplift or the subsidence of the land. We have seen earlier also how uplift or subsidence of the land. I hope you recall that in the case of the plate movement or the convection current, we had discussed about this fact that let's suppose you have a solid land surface or the crustal portion and there is heat provided from interior. it can happen that the central portion starts inflating ever so slightly. On the larger degree, it will appear like inflation. But if you are a person here, for you, the land is moving upwards, isn't it? For you, the land is moving upwards. Or let's suppose the land simply sinks because due to the heat, the internal portion is consumed so much that the land in itself sinks. Now, that is the subsidence of land. So, that multiple upliftment and subsidence of lands which happen, the vertical motion which happens, that is aperogenic. Now, coming back to it here, if land uplift, it affects the house on that land. Is it dangerous? So, it is a similar question to uh, when I say that the fourth range of Himalayas are coming up, and people say that I have recently bought land in north portion of Uttar Pradesh or northern portion of West Bengal or northern portion of Bihar. This is such a slow process. If the land gets pushed up by 1 centimeter or 1 millimeter, you won't even be able to feel it out, right? 1 millimeter. And it happens on such a large area that basically the houses etc they are very very small. Having said that, if let's suppose you are so very unfortunate that the upliftment or subsidence, that boundary lies where your bedroom or your drawing hall is, so in that case, yes, there will be cracks which shall be developed. So in that case it can happen. For example, in the region around Dhanbad, you have the mining town of Jharia. Now, their subsidence is happening because of a very different reason, because of fire which has been ignited in the coal seams underneath. Now, the land is sinking, the land is subsiding. Many houses have fallen there. So, that is a different matter. Now, let's suppose here there's a river which is moving. Let's suppose. Okay. And let us also imagine the river channel in a cross sectional point of view. Let's suppose this is the river channel. Okay. Now, if here you have the presence of water flow, water is flowing in a certain direction. Now, if the land is getting pushed up here, right? Only in this area the land is pushed up in the path of the river by 1 millimeter. 1 millimeter. Now I give you two options. Tell me what can happen. First option is that the river will stop flowing and change its path altogether. Second option is that 1 millimeter elevated land in the path of the river will erode everything in its path, maintain its original flow. So, what will happen? The first case or the second case? What do you think? Very good. Always the second case will happen. 1 millimeter, that too in the middle of the flow of the river will be able to maintain its flow. It will erode any upliftment by one. If let's suppose it would have uplifted by 10 centimeter or 50 centimeters in 1 year, then maybe the river would have to change its path. But 1 millimeter, the river is already coming from here with a force, and there it encounters an uplifted riverbed by 1 millimeter. What will it do? With the force, it will carry it out, it will level it out. So, that is when many of the times you have very unique landforms created where as the land starts getting uplifted very very slowly, 1 millimeter every year or 1 millimeter every 10 years, then the river maintains its path, and all around it there is nothing to erode or carry away the rocks here. So maybe here the rivers will or the land will get elevated, and in the middle way the river will maintain its path. So that is a combination of endogenic, exogenic forces acting together. I'll show you the image of this. When this happens, what does it look like? So if I show you the image of it, here, let's suppose, observe this. Observe this landform. How do you think river is present at this depth? Do you think the river would have dug such a deep valley here with vertical sides here? No. In this region, the river would have always moved like this. The land in between this area has gotten uplifted very slowly. And if you observe this image carefully, you will be able to observe how and when the upliftment happened. For example, all of you are able to see this image very carefully. No doubts in that. This image is clear. Okay, look at it carefully. Observe the bands. I hope you are able to observe various different linings. 4 of them together. Then again here, observe. 4 of them together, 5 of them together. On the other side also, you will find a kind of a similarity. On this side also, you'll find that similarity. I hope you are able to witness this. Here also, observe this. Now, observe this portion, vertical. This portion on the other side, vertical. What does it tell you? It tells you that at one point of time, this region that you see, that would have been at the level where the river is flowing. Over a period of time, slow upliftment would have happened. The river would have eroded everything in its path, but the surrounding rocks, there was nothing to erode it, so they get left behind. Again, another phase of uplift would have happened. Again, the river would have managed to maintain its own path by eroding any upliftment in its own river channel or river bed. But around it, there would be nothing to erode, so its height would increase. Eventually, here, why do you see a vertical line? Because that tells you that this entire process of upliftment has happened continuously in one go. That is slowly and steadily, 1 millimeter every 10 years, it has continued to uplift. And these banded structures indicate that maybe after the upliftment, there was a lull period or there was a period of gap where no upliftment happened for another 10, 20 million years. Again, there was some upliftment. Again, no upliftment, again, some upliftment. So that is how the endogenic forces, they build the landforms, and the exogenic forces, in this case the river, they will continue to form its own path. Okay, so that is the case of the endogenic and exogenic forces. Okay, now aperogenic, basically the continent building forces which lead to the rise and the subsidence of the landmass. And when we say orogenic, orogenic are mountain forming forces. Anything where you hear the term orogeny, orography, etc., it is associated with mountains. So when we say orogenic forces, these are your mountain forming forces. It can be classified into folding. It can also be classified as faulting. Okay, so that is where folding and faulting we have seen. So they come into the category of orogenic, and vertical upliftment or subsidence of landmass, that come into the category of aperogenic forces. Okay, now when we talk about the forces acting from exterior, that is the exogenic forces, these are the forces acting from outside. Forces acting on the surface from outside. Okay, that is the exogenic process. Now, these exogenic processes are of multiple types. You have weathering, you have mass movement, and you also have erosion and deposition. So you have multiple of these processes. So weathering can be classified as physical, chemical, biological weathering. We'll take a look into it. Mass movement can be slow, for example, creep solifluction. It can be rapid, for example, landslides, mudslides, etc. And erosion and deposition can be carried out by running water, groundwater, glacier, waves, ocean currents, winds. All of this can carry out these exogenic process or the forces acting from outside. Okay, so that is the basic and the general classification. So one by one, let us take a look at the different types of exogenic forces. We have already taken a look at the endogenic forces in detail, right? Yes, Twisha, that is correct. Sushmit, mountain can form from different forces like tectonic as well as horst and folding, but now we have diastrophism. Yes, Sushmit, that is correct. Which Rocky Mountain is this? That is actually the region of the Colorado Plateau in itself. Okay, in the region around uh, the southern part of US, you have many such. What is that feature that is known as an incised meander? We will take a look into it. Tanishta, I will talk about the river weathering again. Don't worry. Okay. Now we talk about the weathering. Weathering is what? So, weathering is when the rock in their own place, let's suppose, wherever they are, in their own place due to physical, chemical, and biological processes, if the rocks they break down into small fragments or small pieces, maybe due to biological, physical, or chemical action, any of them, in the same place, if the rocks break down into multiple small pieces, that is weathering, right? All the soil that you see around you, majority of that has been formed because, and I hope we have talked about it earlier in the second class while we were talking about the evolution of the planet Earth. At one point of time, we did not have any soil right up till around 600 million years back. You did not have any soil on the planet Earth, no soil formation, only rocks, volcanic rocks. But then, over a period of time, basically, you had the case where, excuse me, guys, just a moment. Excuse me. So, you did not have any soil formation around up till 600 million years. So, obviously, no plants were in existence. But then, only volcanic rocks were present. Now, over a period of time, the first species which inhabited the land masses were actually lichens. Lichens, you would have heard the name of them, lichens, which is basically a combination of very small, microscopic almost, plant and animal. It is a kind of an algae and a fungi which gets into a mutually beneficial relationship to form a lichen. Now, these lichens, they grow. And you would have seen mosses also. So, in the damp rocks nearby, you would have seen that greenish covering develop. All of us have seen that greenish covering develop, isn't it? Right? They are mosses. Sir, your lectures are more informative than the YouTube professor. Okay. First of all, gratitude for that. But I hope that you are no longer restricted to tell me this line of the book. And as long as it is beneficial, fair enough. It works. So, then you had the case where these mosses they started dominating the greenish covering. Even in your damp cement, the region which has been damp for a long period of time, you would have seen that that slippery greenish covering happens. Those are mosses. types of plants with microscopic leaves. They grow on damp rocks. So, for around 2 to 3 million years, and even more than that, few estimates they tell us that the entire planet, the entirety of the region of the rocks, they were covered with mosses for more than 10 to 20 million years. Now, these mosses, they would grow on the rocks, they would secrete certain chemicals, rainfall would happen, the rocks they started becoming loose. Then the rainwater could carry it away. Eventually, they would break, and you had the formation of soil. After many, many millions of years, around 200 to 300 million years later, you then had the condition ideal for the growth of trees. So that is where it is the rocks which are present around us, which has given rise to the variety of soil around us. So it is also a sum product of the process of weathering. For example, why is it that in regions of Karnataka, Jharkhand, Odisha, parts of Chhattisgarh, you have red and yellow soil? And in parts of Maharashtra, parts of Gujarat, Madhya Pradesh, Western Madhya Pradesh, you find black soil. Why is it so? Is it the case that while God was granting gifts to the planet, they said that no, now red soil is over, now you have to make do with the black soil itself? No. It is basically dependent upon the type of rocks which are present, which weathered down and they disintegrated to form that minor and minute particles. So when the rocks they get broken down in their original position by various action, maybe the action of heating, cooling, rainfall, freezing, melting, or chemical dissolution of the materials in the rocks, any of these, or biological processes, when the rocks disintegrate in their own position into smaller parts by any of these actions, that is weathering. So weathering is basically disintegration or breakdown of rocks into smaller parts due to physical, chemical, and biological processes in the same region. See, again I have a question. Which chapter from textbook? See, I will not follow the exact chapter description. Do you find it any difficulty following it directly from the PPT? Do you need to keep a book open on the sides? Please don't limit yourself like what you used to do in your class 10th or 8th class. I hope we will be able to carry the discussion in much greater and fruitful manner if you are not in the habit of having a book opened up to the side and then basically underlining, okay, he has taught this, I will underline that. Please don't get into the habit of this. It might work for other subjects, but I always feel that will be, for example, many areas here that we have discussed, for example, Shalini, we have picked up areas from Indian geography. We have picked up areas from environment ecology. We have picked up areas which you won't find in the books also. So please don't restrict yourself to these things. Just ensure that you are understanding what is there in the PPT of what is being taught. Are you finding any difficulty in that? Yes, the class and the PPT is sufficient. Kindly pay attention here. So in this case, weathering here, when we talk about weathering, it happens in the place where the rocks are originally present. Happens in the region where rocks are originally and naturally present in their natural setup. Yes. What is also known as in situ. Now, let us understand how these rocks will break or why these rocks will break. Or what do we know as physical, chemical, or biological weathering? So, when we talk about, let's suppose here, a rock, a large rock, let's suppose here, which might be 3 kilometers long, 4 kilometers long rock structure, it can happen. Now, this area will receive heating during the summer, cooling during the winter, subsequent heating again in the summer, cooling again in the winter. That process will repeat itself. Now, that continuous process of heating and cooling, what will it lead to? Cooling leads to expansion of rocks, or heating leads to expansion of rocks. Cooling leads to contraction. Again, heating leads to expansion. Again, cooling leads to contraction. Again, heating leads to expansion. Now, imagine this process being repeated millions of times. What will happen? The rock structure will weaken. Maybe they will develop a crack, isn't it? Maybe they will develop a crack. Sushmita, I'll address your question at the end of the class. Ask this question at the end. Now, here, maybe they develop a crack. Now, in this area, let's suppose the conditions during the winter months, they go to the freezing level. And in the summer months, it is normal. Let's suppose a region like Uttarakhand, Jammu Kashmir, Ladakh, Himachal Pradesh, Sikkim, Arunachal Pradesh, those areas. Now, here, during the rainfall, water will start accumulating here. Water will basically start accumulating here. Isn't it? Water will start to accumulate here. Now, you would have seen in your area also under normal circumstances that various cracks are there in the rocks which are filled with water, right? If you are living in an area where you have a lot of rocks after rainy season, generally your parents and your grandparents would have always advised you that don't go into that area. The rocks have certain cracks, water is filled up, you've never know a snake might be there in that region, etc., etc. You would have seen that. Now, let's suppose during the winter months, the water which is concentrated here gets frozen. Now, when water turns into ice, it expands. Ice is an expanded form of water. Ice is an expanded version of water. We are comfortable with that, that ice is an expanded form of water. Any of us who is not comfortable with that? Okay, everybody is comfortable. So, ice is always an expanded form of water. So, let's suppose this water freezes into ice. So, it will tend to expand. When it tries to expand, what will happen to the cracks? The cracks will be widened because the water now is expanded. Maybe again it will melt, again water will fill up, again it will freeze. So this process might lead to the deepening of the cracked structure, and the rock might break down. So here the rock has broken down. Why? The rock primarily has broken down here because that continuous heating, cooling, freezing, melting actions, any of them getting repeated multiple times, has weakened the rock structure. So these physical forces of nature, they have led to the breakage or the breakdown of the rocks, right? So that is what we refer to as the condition of physical weathering. So this is what is physical weathering. Then what is chemical weathering? Now, chemical means that by action of, let's suppose, rainwater or seawater, the materials in the rocks are able to dissolve themselves. They become soluble. So let's suppose here you have a region which is dominated by calcium. Calcium. Why I say calcium? Because calcium is soluble in water. Let's suppose this is a region dominated by calcium. Okay. Now here, if you have rainfall in this area, let's suppose, here you have rainfall. Now, this rainwater will dissolve these materials. Okay, this rainfall will dissolve these materials ever so slowly and slightly. Let's suppose that water then evaporates or moves out again after 10 years. Again, there is much amount of rainfall in this area. It will keep on dissolving. Eventually, what will happen? The entire portion where the calcium is present, water will be able to dissolve that and move out. Now, if that region of water or the material getting dissolved and moved out, now that happens, then what is left behind? You have the fragments of rock structure. This portion of rock remains fragmented. Now, this portion will separate, isn't it? Now, why has this portion broken down? Is it because of the physical forces of nature? No, it is because of the chemical action. The water reacting in a, there is a chemical reaction with water and the material which was present in the rock, in this case calcium. So if there would not have been chemical action, then the rock would still have been intact. So that is the process which is referred to as chemical weathering. So that is the breakage of the rocks due to the chemical action. Okay, comfortable up till here? Breakage of rocks due to chemical action. Okay, now then there is biological weathering. Now in this case, I want you to recollect your own memory in whichever part of the country you would be living by. You would have old government buildings and old government structures nearby. Maybe old houses, maybe old offices, which are not well maintained. There, have you observed, or the old boundary walls, have you observed that from these walls, sometimes small plants they start to come out? Have you observed that? That small plants they start to come out, right? Many of you would have observed that slowly and steadily. If you visit the same region, let's suppose after 2 years, you'll find that rather than one plant, now you have a whole bunch of plants growing out of that area. The region of the crack has widened. You would have observed that. If you go back to the same area after 10 years, You wouldn't even identify where the walls were there, only plants would dominate that area. Observe that. Now, similarly, in the case of the rocks also, let's suppose you already have a crack which has developed. A crack which has developed. Now, in this crack, let's suppose there is a growth of a plant-like structure. Crack might have developed due to chemical or physical action, any of them. A small plant will develop, the roots will start penetrating. Now the roots will try to extract the minerals from the surrounding. After some time, maybe another plant will grow from here. After some time, another plant grows from here. They will all have their roots. Now don't think about it that why plants are growing on rocks and not on soil. Because wherever the crack has developed, if ever you have seen the crack of a rock, if ever you have felt that crack of a rock, it has got tiny particles that if you scratch the surface, you will get some tiny particles. You would have witnessed that if you have basically explored the region around you. And I gather that not many of us are bookworms here. So most of you would have experienced that wherever a rock has cracked or a wall structure has cracked, if you feel that crack, if you rub your hands around that crack, you get some tiny particles associated. Eventually it is those particles which make up the soil. So basically the plants, they find the strength, their roots, they lodge there. And how do the plants come there? Maybe a bird has, or a bee or a fly, they have carried the small seed or the pollen in that area and it has grown, right? So that is how you will have the plants growing there. Now they will significantly intensify. Now over a period of that point of time, the roots will start deepening. They will want to get more minerals. So as they deepen, the cracks will also deepen. As the cracks deepen, maybe a small rodent will come here, a mouse, a small rodent, mice-like structure might come here, a mice-like organism might come here. They will start digging. What will it do? It will weaken the rock structure. Eventually, it might have a depth. The rock might be broken. So that is how the rocks are broken here by the biological events, by the biological beings. That is what is known as biological weathering. Okay, so you have physical weathering, chemical weathering, and also, just a moment, guys. Excuse me. So you have physical weathering, chemical weathering, as well as biological weathering taking place. So all these events, they do happen, right? Now, if I ask you, out there in nature, will it be the case that in this place only physical weathering will happen, in this place only chemical weathering will happen, in this place only biological weathering will happen? Or will it be the case that all these weathering processes can take place simultaneously? First option or the second option? What do you think? Could always the second option, right? So that is how basically out there in the nature, these forces, they act simultaneously, leading to the breakage of the rocks. Okay, I hope we are comfortable up till here. I saw a plant in the building's third floor corner. That place has got no soil or water source. So see, Ashish, you had also asked this question. Lakshmi, you have also asked this question. Basically, these plants, it is not those kind of plants which will grow in that area which will have lot of water requirement. That is why you will find such plants to be growing very quickly during the rainy season, and plants requiring very little amount of water, not that great. And they will, the rocks basically, or the walls that you see, now if it has rained, Do you find this phenomena that even after 2 days, the if it has rained very heavily, the walls are a bit damp? You would have observed that, all of you, right? That basically you have, if it has rained significantly, then outside walls they remain damp for a couple of days if there is not significant sunlight. So the what does that mean? That the rocks, they have the ability to absorb moisture in certain cases. Now that moisture is sufficient. And then what is the purpose of soil? Soil provides the plants with nutrients and the strength to stand, right? That is the purpose of the soil. So when we talk about these regions of the walls that you are talking about, there that strength is provided by the rocks and the wall itself. And basically, the nutrient is provided by the small particles around the region of the wall structure. Because the walls that you see has is made out of bricks. Bricks are made out of what? What are the bricks made out of? Soil. It is the hardening or and the baking of soil which leads to formation of bricks. So if the bricks are broken into two or a smaller fragment, won't it be able to provide the nutrients that the soil had? Along with that, you will use cement. Cement provides calcium, right? So that is how they are able to sustain it. I hope that is understood, right? Now we come to the portion of mass wasting. Now, mass wasting is what is also referred to as mass movement. This is also what is mass movement. Now, what is mass movement? When you basically have the rocks or in any particular area, let's suppose there is a slope. Now, if there is, let's suppose, lot of loose soil which is available. Loose soil means that there is no such plant binding the roots binding the soil. The soil is free to move, let's suppose. And then in this area, you have excess amount of rainfall, huge amount of rainfall. Events like cloudburst has happened. Now that water will form a kind of a solution. It will have the ability to carry that soil. Maybe few rocks are present, loose rocks, they will also be carried. So you have a bulk movement at one go. So bulk here is represented by the term mass and movement is represented by the term wasting. So mass wasting is the movement of rocks and soil down the slope under the influence of gravity. Okay, because you will never observe this kind of a motion if, let's suppose, the ground is flat. Let's suppose there you won't observe this motion. But in the same area, if let's suppose you have the ground feature which is somewhat like this. Now, even if there are loose rock structures here, the loose rock structures will start to fall down, tumble down. So, influence of gravity is a must. If let's suppose, now if I ask you a question, let's suppose that I give you two different scenarios and let me know. An area is having the presence of loose soil and rocks in this manner. Loose rocks, right? They're not very deeper ones, very loose and topsoil like this. And another region, let's name this region as A. Another region has got the pattern like this. Here you have some loose soil, here you have some loose rocks. Let's name this as B. Where is it that the materials will fall with a greater force and more quickly? A or B? Always B. Why is it the case? Why the materials will start falling suddenly and with a greater force in the case of B? Why do you think? Gravity and the slope factor. So slope factor manages to influence the amount of the vertical component of gravity, right? So steepness of the slope ends up determining not only the amount of materials but how much materials will fall down. Similarly, now if I give you another example, let's suppose if I have an area with a similar slope, loose soil and rocks are present. Now in this area you have high amount of rainfall, very heavy amount of rainfall, continuous rainfall for 15 days. And this area maybe you have less amount of rainfall, it has drizzled for half a day and that's it. So where is it that the materials will fall down the slope or move down the slope quicker and in greater proportion, A or B? Always A, isn't it? Why? Because that excess amount of water has basically managed to carry a lot of materials along with it. Water provides that fluidity. Similarly, again, I will give you another example. So water content also ends up determining, that means that how much amount of materials will move. Now, if I give you another example, let's suppose here, in the first case, I had lot of loose soil here. Let's suppose in the second case, I have hard rocks, very hard rocks. Rocky region like the Chota Nagpur Plateau, etc. Let's suppose. Now here, some loose soil is present on top. Now here also you have equal amount of rainfall as the first case. Now in which case out of A and B, will you have more materials coming down the slope? Always A, because you have loose soil, loose rocks. In the case of B, everything is hardened, fixed to the ground. So volume of material which can come down the slope, water content, and the steepness of the slope, along with the influence of gravity, these are the chief prerequisite conditions required for any kind of mass movement which happens. Steepness basically refers to, this is a steeper slope, this is a gentle slope. So steepness is how vertical it is. This is a gentle, very less steep. This is very steep. That is the characteristic which determines this. Now, here, influence of gravity is a must. Now, here, if there is weathering of rocks, if there is weathering of rocks, more loose materials available, materials available for flow, for movement. So, mass wasting is accelerated. Having said that, weathering is not a definite requirement for mass wasting to happen, because that region might have loose materials already present in that area. Okay, so having said that, however, weathering is not a prerequisite for mass movement. Okay, keep these things in mind. With that, I will end the session here because of health issues. I won't be, so I think we will end it here. First of all, thank you for being so very patient. And despite the multiple disruptions, you have been more than patient and you have been supportive enough. I hope today's session has been helpful to you. You have gained some insight. Till we meet again, do take care of yourselves. And basically, I hope that the health gets better. Then, couple of questions, Vikalp. How does the rocks provide minerals and calciums in the case of the wall for the plants? Is that under the influence of water? So you have small particles from which the root nodules can extract the important nutrient, just like from the soil. From the soil also, it is the ions and the elements which are extracted from the particles by the roots, just like that. Sushmit, what is epirogenic force? Epirogenic force is basically the kind of upliftment and subsidence of the land which can be caused due to heating, cooling, etc. That is epirogenic. Okay. Now, Sushmita, you had said that basically about second Himalayas. I'm living in Purulia. So Purulia region in Sushmita, I had told you, I had mentioned Purulia because again in the region of the Damodar River Valley itself, that is again the extent of the Peninsular Plateau, the Chota Nagpur Plateau. So that is where even in that area there has been volcanic rock formation, and that is why you have the multiple upliftment and subsidence creating a rift valley even in that area. Okay. And weathering is not a prerequisite. Basically that means that it is not the case that unless and until weathering will happen, the mass movement will not happen. Weathering can happen either, mass movement can happen either ways. Okay. And is plate tectonic movement ultimate master force? No. If you have to think about it, Sushmit, think about the convection current. Convection current is the ultimate force which determines all of this. Srilata, how to remember plate distribution and mountains? Again, it is very simple. Just repeat the same thing at least 10 to 15 times. Look at the same area 10 to 15 times. You will get a clearer picture. Twisha, see, when you will study for UPSC, you will get the exposure. You will get to know the world around you. It will always improve your personality as well. It is not a zero sum game that if I do UPSC, I study for UPSC, I'm getting dumber on the other side. No. Basically, that is what time distribution is about. Let's suppose you study about the country, you study about the world, you get exposed to newer realities, newer political scenarios, social scenarios. It will improve your overall understanding. Girish, just look at the physical map, look at the various areas, explore in which countries they are in, the regions that we have talked about, understand why those regions are present in that area. First of all, we have discussed about plate tectonics and continental drift. That in itself should give you enough clue. Okay. Shalini, you have to remember, you have to repeat this. Okay. Ashish, you can revise with the help of the NCRTs, more than sufficient. Yes, Lakshmi, that is correct. So, Colorado, Ozark Plateau, Nikhat, map it out. That is where we'll end the session here today, guys. We meet again tomorrow. Take care of yourself. Goodbye. Thank you.